Thank you everyone for joining us today. We're going to be learning about robotics and discussing examples, real-world applications that you can use in a K-8 classroom and beyond. So my name is Graham Ryland, and I work with a company called Wonder Workshop, and I'm really excited to be here with you all and to speak with Rich. So thank you for joining us, Rich.
Yeah, it's awesome to be here. Really excited to talk about robots today.
I've been looking forward to this conversation all week. And but before we jump in, we have to say thank you to our friends at edWeb for making this possible. So you can visit the website there down below in order to join edWeb and get all their great content. It's a great community. I really love everything that they're posting online, and I feel fortunate to be part of this community. So again, my name is Graham Ryland. I'm a senior product manager at Wonder Workshop, and we make educational robots that get kids coding in the classroom, and we do it in a way that allows you as educators to manage it, to control it, to deliver it, these 21st century skills in a way that kids can have fun, that they can enjoy a story, enjoy, learn computational thinking, and do it all in the classroom. And I'm here with Rich Mahoney.
Hi everyone, I'm Rich Mahoney. I'm the CEO and founder of a company called Seismic, based here in Menlo Park, California. I've spent my entire professional career working on robotics. Have a PhD in engineering from Cambridge University, did research on robotics, and quickly realized that I was more interested in doing product development and transfer of robotics into real applications than I was in doing research. And after a lot of different roles and responsibilities, I ended up starting this company, and we're doing a really interesting application of wearable robotics integrated into clothing to provide power assistance to help people be more mobile.
That's great. So Wonder Workshop is located here in Silicon Valley. It gives us a unique opportunity to have a finger on the pulse, to understand what's happening in the world, the startup world, in technology. And we take that information and we do our best to give it to you. That way you can prepare your students for the 21st century skills that they're going to need in order to be successful in their career and in their life. And so, Rich, you're hosting us here at Seismic, and you have a demo of your product.
Yeah, we actually have a prototype of our product here, and Seismic is it's interesting for me after doing robotics for so long. One of the things that we realized in order to be successful for this wearable application is the need to innovate around something that people are more familiar with, which is clothing. And so we really see ourselves as an apparel innovation, and we are introducing a product that looks like what's over my left shoulder here, something you would wear under your clothes and be able to get an extra 20 to 30% of strength from that clothing to assist with your mobility for everyday life. And I sometimes say this is a super suit for everyday activities. We generally feel like this is something that should exist and is a pretty challenging task, but I'm really excited about beginning to introduce that product in the market this year.
That's exciting. So enough about us. We want to hear from you. We want this to be a conversation and not just a one-way blast of info. Please dust off your keyboard and tell us a little bit about yourself. I know that we've already had a few folks share where they're from. Share with us your role in education. That way we can spend the time to help format our conversation, help bring you the information that you need to be successful in the classroom. So there's after-school STEM educators, technology coaches. Jonathan is teaching in Maui. Michelle is an educational librarian. That's really neat to see how the variety. So a lot of K-8 grades 3 through 5. This is great. I think we have a lot of great information to share with you. And then again, take a moment and share with us what you expect from us. Help us to deliver the information that is most valuable to you. So, wow, a foreign language instructor. It's fascinating how coding is being. Slides. There they are. Great. So take your time, and anytime during this conversation, please jump in with questions that you might have. Help us to slow down and answer your questions. So understanding robotics, how to effectively start a robotics program, robots after school, and just simply where do I begin? So Dash and Dot in Tech Classroom. That's actually, I don't know if you can see the video, but we actually have Dash and Dot in the room, in the building. All right, so let's get started. So a quick summary. My great passion is robotics, and that's been a central theme in my life. And from a very early age, 8 years old, I actually remember a very distinctive moment watching PBS and seeing the MIT Leg Lab, a robot on pogo stick legs running on the treadmill, and jumping in the air, doing a front flip, landing awkwardly but recovering and continuing to run on the treadmill. It blew my 8-year-old mind, and it acted as a spark that led to a flame of education, pursuing a degree in engineering, a focus for my career. I mean, just that simple example of robotics being applied, it was really transformational for me. And so my passion is for us to bring some of these moments of wonder to your students and give you the. So another big piece of this is dispelling some of the myths and some of the anxiety that is out there. You know,
I think that, like, if I look at my introduction to robotics, actually came more from just I love science fiction. I've loved science fiction my whole life, and the fact that robots are a big part of science fiction, and then what is fiction and what is real, and then and how do we actually get those things that aren't real to, like, how do we know the difference, and then how do we help to make those things real that should be real. And so the myths are part of that, right? Because it is such a big part of science fiction as well.
Yeah, and not just science fiction. I don't know how many of you saw the Super Bowl this year, but it was saturated with robots. I mean, robotics has really entered the psyche of the public. And something that I noticed is in every case, without fail, it was an anxious moment. It was a moment of taking our jobs. It was a moment of making us feel strange. It was there was a uncanniness in every aspect. But these are not real robots.
Yeah, I think that's the biggest thing. Like, when I'm sitting watching with my family, I'm just seeing this, and even I'm yelling, like, "Look, more salacious use of robots for advertisement." And the thing is, as Graham is saying, every picture that you see here, not one of these robots is a real robot. And I would bet that every one of them, the one on the far left might have some reality to it, but the Sprint one is CGI. The Simplest Safe one is the Michelob one is CGI. Like, these aren't even like physically real props. They're all animations that they're creating.
So I love that there's robotics that are coming into our daily lives, but it's too bad that they're not real, that they're not actually serving a purpose. I think Amazon is the most real in this scenario, and even it decided to throw a bunch of really wacky applications.
Right.
So
I think that's also what we want to accomplish in this. In the time we have is to actually, in your role as instructors, is to help people decipher and kids to know how to decipher what's real and to understand
what is real.
Yeah, and so first let's think about like what is a robot, and this is I have 6 children, and I always tell my children, and they have modest interest in robotics, and I always tell them if they ever get stuck with my robot friends, is they should just ask them to define, hey, what's your definition of a robot, and everyone will spend the next 2 hours fighting over each other, and the reality is there are some published definitions, but the way I think about a robot is this slide is something I put together a long time ago. And these are sort of important things to remember about what a robot consists of. So the idea that it's reprogrammable and multifunction. So it's not just doing the same thing, that it's including sensors, and those sensors are providing information about the world it's interacting with and helping it to make a judgment about what it should do from its programming. And then this last part, which is the one that often creates a lot of challenges, is it's normally doing things that are ascribed to humans, and something that a person is doing, and now you have this machine with a little bit of sensing and thinking that can now do that. And the why do we want to do it, which is sometimes overlooked, is like sometimes we don't want to do these things. Like, right. do we really want people working in dangerous mines or fighting fires in dangerous situations? Other times we don't have the time to do it. So there are things that just take a long time to do, and then so there are definitely some things that robots can do better. They can do repetitive tasks over and over and over and over again without getting tired and without making mistakes, and those are that's useful for us. So so one thing, don't get caught in worrying about a specific definition of a robot, but more think about the general idea of what a robot, the purpose of a robot.
Yeah, and I think there's definitely some categories that you can identify, but there is no universally accepted definition of what a robot is.
Right. You can go to some organization, Industrial Robotics Association, may publish a definition, but in the end, it's really hardware that can communicate, sense, and think and do something. And I think this idea that if it can adapt to new tasks, then it's a robot. If that same hardware or that same system can do something different, then it's a robot. If it's doing the same thing over and over and over again, just like printing press, then it's just automation. And that's, there's no, it doesn't even really matter. And I think this is one of the things that we see today, that people use the word robot as an important, it's such a general word, and it really captures a lot of other meanings when you start to use it.
Because we're living in a technology saturated world, and a microwave is programmable, it acts upon the world, it moves, but nobody would call it a robot.
Right.
But I think you could stretch the definition of automation to say that yes, it does do something over and over again in a helpful way.
Right. So I don't think it's worth spending a lot of time like defining a robot, and I think the other thing that's often overlooked, and you'll go into this a little bit of in helping people try to understand what is a robot, but there are tons of things that are robotic, printers that people have in their homes. That is a form of robot, and people should feel like there are things that are robot-like that have made it into the real world already.
Yeah. So help us better understand, where, it's not black and white.
Right.
And
right.
So help us paint some colors to describe, to give kind of a rule of thumb for what we're seeing in right. today's.
So I think it's really important, and this is, I give a lot of talks on robotics, and one of my key messages right now is that we actually haven't accomplished as much in robotics as it appears that we have, given the amount of Super Bowl commercials and other attention that robotics gets. So I put together this next couple of slides, and hopefully this is an easy way for you to, for yourself to start to assess the reality of robotics. And I think there's nothing wrong with robots that are not real, but we just want to know that they're entertainment or they're fictional or they're used for some other purpose. So my mission for my life and my career is to create robotics that has an impact, that has a real value. And in this chart, that impact, I'll say, is something that's made it to become a real product, something that is in the market and it's helping people solve a problem. And so on the left, on the on the x-axis, there is the number of sales, and on the far right, think of something that's sold 100 million or more, and on the left is something that's just research and conceptual. And then on the vertical axis, it is how complicated is the robot versus like a very simple robot on the bottom. And so anything.
Let me just read because we have slides. So something that's to the right is something that's having an impact on daily life, on humanity.
It's real.
Yeah, it's actually something that you can maybe go buy. And then something to the left of it would be research and development. It's something that maybe you can't buy today, but you can see a demo of it on YouTube and it looks amazing. And maybe it worked that 1 out of 100 times that they tried it, and they got it on camera.
Right, they're solving problems. They're doing research. They're advancing the field, but it's not something that's going to impact your life until it actually is in the market. And I think what's important is that upper left corner are things that are more complicated and sophisticated, and the bottom, upper left corner and the bottom left corner are things that are like not that functional, not doing that much. So
you've got some examples,
right? Yeah. So to understand that, so to take something like a car. This is where a car would sit. Like there's 80 million cars worldwide that have been sold just this year alone. And so a car is actually relatively low function, low purpose. It's doing one thing. It's driving around. And then if we now start to think about where do robots end up on this? So these two robots on the far left, everyone knows on the bottom far left, C3PO, and he's like an iconic robot. But the thing that I highlight is it's not real, and it actually has there's no functionality as a robot, as a machine. It's a person inside of a suit representing an entertainment view of a robot.
Wait a second. C3PO is not real?
It is not real. It is a science fiction, awesome movie. And again, it's nothing wrong about the excitement of that, and we relate to robots because they, especially C3PO, because they create human qualities and make them part of the story. But in terms of
the bottom left-hand side, that's where the Super Bowl ads live.
Yes,
those
exactly
are
right.
Those are fun and engaging and quick.
But they have no functionality. They're either computer animations or simple figures, not real robots. And then now if you look at the industrial robots that have been around now for 30 to 40 years, there are 1.5 million of these robots in place around the world. It's not that many, compared to cars annually. So I think that like the important thing, industrial robots are the most impactful in terms of helping us to manufacture goods. They've been around the longest, so the first to really get impact in helping kids understand what's happening. Like that's the state of the field for the most part, those kinds of robots. And this Atlas robot on the left that a lot of gets a ton of coverage, and I know the CE Mark Raybart was actually the person who created the videos that got Graham interested in robotics. He's running Boston Dynamics. He's led the team that developed the Atlas robot, and it's a tremendous robot, unbelievable technical achievement. But it's an R&D, still an R&D prototype. It's not out in the real world. There's nothing. People will say, ask me, how do I defend myself from that robot? And I say, wait 15 minutes for the battery to run out. Like it's a pretty, there's not that much there that is ready to be used right now in the market.
Yeah, it's really doing the things that it looks like it's doing, but and so it's above the horizontal axis, but it's not ready for the mass market, not yet. So what are some other robots?
Yeah, and then like we don't have to spend a lot of more time on it, but I do think it's important when you're interacting with children is to really help them understand what is real and what is not real. And what the message that we'll keep emphasizing is that children getting into robotics now should enter it believing that they can impact what is real. They don't have to react to some fictional robot and think that this is already done. They actually we need people to get involved, and we'll keep emphasizing this. So I saw a question of asking if Atlas was used in the military. It's not. It's a research and development. The military funded some of it, but there is no use of it in any application right now beyond R&D. And that's fine. There's nothing wrong with that. And so the other on this chart, just to kind of summarize on the left, these two areas that at the bottom left corner, tons of attention for decades in science fiction and movies, really great entertainment, but just not real. And it's important for people to know that there's no element of robotics that has that capability yet. And then the upper left-hand corner represents the state of the art, and a lot of the media love to cover this, but again, there's no impact, there's no sales, and there's still a good amount of time before any of that will be available. And so the market right now are more simple robots for industrial applications, medical applications. Roomba, people will know. Roomba is probably the most successful consumer robot.
It does one thing really well.
Right. Very simple, and I think they've sold maybe 30 million or so worldwide so far. And it's a great. I actually just bought my first Roomba like a month ago, and I really I love how it works. So.
That's fascinating. I know how much cheaper a Roomba is from a KUKA robotic arm, but I mean what you're saying is there's significantly more vacuum cleaning robots than there are industrial robots.
Right. That's crazy, right? So industrial robots, 1.5 million installed in the entire world, over 30, almost 40 years, and Roomba in under 10 years has sold 30 million, and still not as many as cars sold per year. I don't know the number of actual vacuum cleaners sold per year, but it's still less than Roomba. So this whole lower right-hand corner represents where robots will emerge. So you might have seen iRobot just introduced a lawnmower version of their robot for mowing lawns. We're starting to see now cars being talked about being autonomous. And so this next slide actually is where we can start to say like that these robots that you see now as entertainment robots in the bottom left, someday we should have those robots. Someday we will have robots that have that capability, and that will be transformational. That will actually change how we live our lives. And I think there's sometimes a fear about that, but it's fundamentally the same as the internet or the cars themselves, any other technology, electricity, that it does bring enormous impact and improvement in quality of life. But there's lots of other things that we have to manage as well, and robotics will be the same.
Amy asked an interesting question. Amy from Ohio. Are students disappointed in the beginning with the real robots after being exposed to the fictional robots?
That's not my experience, actually. My experience is that kids like the control they have in like creating robots and seeing them emerge. And I mean, you know this from your previous company, and what kids are empowered by that ability to design and make something that actually works and does something in the world, and they don't worry about the scale so much of it.
Right, and doesn't have to know however many millions of languages that C3PO knows. If they're able to do something and bring that idea into reality through robotics, right? That's very powerful. We've seen that in Wonder Workshop a great deal. And then I think that having the top or the bottom right-hand corner, that's where we're seeing single-use single-purpose
Right.
robots that do one thing really well, and we're seeing more and more of those. Finally, more and more of those types of applications.
Yeah, this is a good example. If you think of a vacuum cleaner giving it some intelligence, and now it can clean your house on its own, right? So it's
moving up,
right? And now we're giving more intelligence to cars, and they're starting to move up. So, and then eventually we'll also get some of those more sophisticated robots start to make their way over. And like, what's the timeline of those blue lines? Like, it's probably still 30 to 50 years before like we'll start to even see the beginning touching on. And guess what? All the kids you're teaching are going to be in the prime of their careers when we're getting to that stage.
That's huge. And we're about ready to leave this graph. So if you do have questions about this, if this doesn't make sense, please let us know so we can help explain a little bit more. So again, I think there's definitely an opportunity for young people today who may take the fact that they have robots in the classroom for granted. They take that they have a robot in their home for granted, and actually be able to make that jump of imagination and creativity to start building taking these tools that everyone has access to, and do something amazing.
Right, and I think the messages from the media and the messages in the general awareness are that robots are something that we have to be react to, and I think your first mission is to help people understand that robots are something that will emerge from our work, and that we need children to be involved to help develop and program them, and that the future benefit of that will be good. Like the opportunity is for them to create that good future.
That's a great segue. You've been working here in Seismic as well as SRI before that. You've worked on some pretty remarkable robots over the years. We've known each other for about 10 years, and in that time, I've really been impressed with your career. Maybe you can share with me and with all of us here, some high-level observations about the status of robotics now, and maybe we can also describe what comes next.
Right. Okay. Yeah, I have been really fortunate. I've been in Silicon Valley for 10 years. Before that, I lived in the Philadelphia area and worked on medical rehab applications, and always working on like that really hard place of getting new emerging prototypes into the market. And here in Silicon Valley, as the director of robotics at SRI International before working on spinning out and doing Seismic, we worked on a number of doctor programs. We spun out a few of our own companies, and we also helped to build links between other companies and venture capital investment. And one of the observations that I really took from all of this, and I had it's part of why I actually transitioned to this, is being able to there's not enough that's being accomplished in robotics, and that we need more effort. We need people to be like leaving academia and getting involved in robotics, people not being afraid to jump into new companies, and kids wanting to get in to robotics as a career. And yeah, there's definitely strong engineering and software needs there, but there's tons of other skill sets that are needed in any kind of robotics application.
Yeah, earlier in the chats, in the chat log, I saw someone make the distinction that robotics is not STEM, science, technology, engineering, math. Right. But you need engineers, you need scientists, you need graphic designers, you need business people,
managers, marketers. It's the people skills that you need to coordinate all these disciplines are actually, so I'm an engineer, but I've found that my role in helping to manage the communication between software engineers and electrical engineers, mechanical engineers is, and also think about the customer needs are actually, it's not related to coding, it's related to other kinds of skill sets.
And I think you see, as I see, there's a groundswell of technology, of interest, of market opportunity. Mm-hmm. And I think that when you say personal robots are dramatically missing from our world, that's something that will be solved soon, and it'll be solved by creative young people. And a diverse group of
right. And it's really, don't lose sight of the fact, like think of Google or Apple or HP, or like those companies are stories about people that had some knowledge, some technical knowledge, some technical exposure, but also had an insight about a product and a company and a market that they could. So I always make this point that robots are about people, and at all of the companies I know in the Valley, there are people doing robots for apple picking and for strawberry picking, robots for new industrial applications, but they're all about the people that had the idea. You probably heard about this company now called Creator that's doing robotics hamburgers, making hamburgers, and they opened in San Francisco late last year. Alex, the founder of the company, his family owned a burger joint growing up, and he saw the difficulty of people working in the kitchen, and he wanted to bring those people out into service areas and automate this other part of the business.
Well, that connects us to the elephant in the room, which is, aren't robots going to take all of our jobs? And I think that question is debatable. I'm really curious to get your take on it. The first industrial robot that I could find was the Unimate, and it was used by General Motors in the 1950s. I found a great black and white photo. You see how far away they're standing from the robot.
Right.
And so these robots, this automation and these robot arms, some of them can weigh more than a truck.
Right.
And typically they're being caged in a safe location with sirens that are flashing actively on the cage, giant red buttons, so that if it nudges somebody, that can cause great injury. And so there's all these red buttons to shut the robot down, to stop it from doing its job. And so I think this fear of the danger of working in close proximities with these robots make us feel a sense of territory. They have their space and we have our space, and their space is starting to grow into our space. But I think there's a really neat trend that's happening, and the trend that I'm seeing is something that's called Cobots. And these are robots that are in close proximity to humans. They're being used. They're being used alongside and intimately in contact with people who are doing a job and being able to do more because of the support of the robot. And I think that actually connects pretty well to your new company.
Yeah, definitely. Like and actually a lot of the robotics that I've done in my career has been looking at how we can use robots to help people with specific spinal cord injuries or recovering from stroke. How can we have a robot assist with a higher quality of life for those individuals? And so I've been really looking at this robots that have a close interaction with people, and that is the big trend. And so the industrial robotics is you started out just sort of alluding to jobs, and my view around jobs and then relating to people is that it is robots will impact jobs, and in a way that business people are going to drive and business needs are going to drive, but it's always going to change the dynamic. It's not a one-to-one, this job is lost. And so, our country tends to equate jobs to quality of life, and that I think that and robots tend to get connected to taking jobs away, but it's a lot more complicated to that. And I like to focus on those jobs that people aren't doing now were horrible manufacturing jobs. Right. And there were people that were being crippled and also injured by doing those jobs. And then robots came in and were able to do two things, actually, take people out of those dangerous situations, but also what we're now creating with those robots. So if you look at the cost of manufactured goods today, it actually, the relative cost has stopped increasing since the mid-1980s. And I think something that's, it's maybe a sophisticated argument, but we now all have access to those manufactured goods at a cheaper price than other services that we were getting. And I think that means the overall quality of life that people have, we can access more because of that impact of robotics on manufacturing. And this whole Cobot space is really now about how do we move from this first service industry of manufacturing to other service industries. And
yeah, so not just you can get a lamp cheaper, but now you can get a service. You can be empowered to do things using robots.
Right.
And so you've done a lot of work with individuals who have disabilities, who have had injuries. Maybe you can share a little bit about that.
Yeah, it is really interesting that I remember working on a robot for stroke rehabilitation, and the therapist would say, "Oh, you're going to replace me," and I would say, "No, I'm going to immortalize you." Like you're. And one of the things, if anyone's ever dealt with someone recovering from a significant injury, it's actually the amount of time that you get with a therapist to work on your recovery is very limited, and typically people recover better with more time doing therapy. And so robotics is a way that you can actually automate some of that therapy and allow people to get a higher level of recovery, and also allow therapists to then spend their time focusing on individuals in a different way. So this robot I'm showing here is a robot that I recall from early in my career, and this is a good way to help you understand that a robot that was designed to help feed someone who has limited hand motion could very easily be reconfigured to help with shaving or applying makeup. And this idea, that's really one of the opportunities with a robot, is to be able to expand and do lots of different activities.
That's what we're missing today. I mean, we're missing that general application robot, that platform that can not just clean the floor, not just mow the lawn, but also help support you in living independently.
Right.
So we're talking about a groundswell. We're talking about this. This is something that is robotics entering our daily lives in a complex way. Is right around the corner. What's driving that innovation?
Yeah, so it is an interesting time. One of the things, if you look at all the pieces of a robot, you need some sort of computer, some sort of sensor. We talked about those things earlier. And what's really interesting is the ability right now that with the consumer electronics industry over the last 25 years or so, we've seen a lot of new technologies around microprocessors and sensors and computing that have all become much more accessible. They have whole development platforms associated with them. And so there is now, with just your smartphone, you have almost everything you need to be able to control and interact with a robot, with some kind of physical, and at a price. Those first robots you're showing were hundreds of thousands of dollars. And now an industrial robot is $30,000 to $70,000 depending on the size of it, and you actually have most of the computing power you need in your smartphone today to control a robot.
That's amazing. So what kind of applications do you see as being the next big thing?
Right. And so if you look at what the trends are right now and where the needs are, this list describes them. But going back to this discussion of labor and jobs, that like right now in the United States, there actually is a labor gap. There are a tremendous number of industries that are having trouble finding enough labor. Like, so I have a friend who started a company doing an apple harvesting, and the apple orchards are having trouble finding the seasonal labor that they used to have, partly because of the quality of opportunities that are in that they have otherwise. But so the applications you see here are things that are more service industry related. There's a lot more competition for those kinds of jobs.
Yeah.
Retail, restaurants, agriculture applications are all really starting to emerge right now.
So let's just take a moment and recognize, our group is looking for a way to take this information and use it in the classroom. One of the things that I've had a lot of success with, I spent a lot of time in the classroom with user testing and volunteering and just learning about, teachers are my all-time favorite people. I'm actually married to a first grade teacher, shout out. And I think a really good question that you can ask is, what in your world, if you had the choice, if you had the power, would you make smart? What in your world, in your daily life, would you roboticize? Would you be able to bring an intelligence to? What kind of problems do you have in your community? What issues does your family have that is that's causing pain? That's causing sleepless nights? What are the things that you have going on right now that you could bring robots into a solution for that? And I've actually seen a ton of, and when I sit down with students, and these are, we focus at a Wonder Workshop, we focus primarily on elementary school, and all the way up through 8th grade, so first through 8th grade, and it's amazing what kids come up with. Being able to just that jump, that imaginary generative step of creating a solution to a problem. I think that's a big part of robotic education.
Just to maybe think about, my son did I think it was kindergarten. He did a picture of a robot for something he was doing, and I was looking at it, and then I realized that the robot had a little message that it was saying something, and in the voice box it said, "You are cool." And I was like, that's exactly like, here's this first grader creating a robot that's telling him how great he is. We have actually in his whole life had discussions around what we call the encouraging robot, like having a robot that's just telling you that you can do it, how great you are. And it's really like a lot of insight for me from just the way he thought about what that robot should do.
And this is a fascinating time where we can start incorporating socio-emotional skills into technical subjects. I was asking a second grader the other day, what would you do? And their opinion was, I'm going to make a crane smart so that when I'm stressed out, it'll go pick things up faster. And so that, just really interesting concepts. Well, can you actually program that? Can you bring an application to bear? And I think we live in a really remarkable time where we have tools that you can actually do some of these. You could have a bulldozing robot that helps clean your room.
Right.
You could have something that can grab something off the floor, move it.
And I think that's I've seen a lot of questions come up from people saying, how do we get started? And I do think if you look at the creating robotic clubs or projects around that, it's not about just a manufacturing robot anymore.
Yes.
People should be able to think about, so brainstorm in a class, come up with something that the class agrees would be a great solution, and then work on creating that. And there's tons of resources now to be able to do that. It's more accessible than ever.
Yes. So let's move through these next few slides so that we can get to questions and answers. I think we really hit on the fact that this is a new world. This is a unique time in history,
right.
And a lot of this technology is being democratized.
Yeah, and so this one of my basic ideas is that the robot does connect you from the physical world to the information world, and that information can help you understand the quality of what you're experiencing. But that if you have a robot that tells you you're cool or that can clean your house, now everyone has access to that service, and not just from a cleaner coming in or doing it yourself the time you get back from. So I think that there is a good robot story, and good robot was our lab's motto, and it's really about capturing the best performance of people. What's the best outcome you can get from therapy? What's the best outcome you can get from harvesting apples? What's the best outcome you can get from cleaning? Learning those and then not replacing, but then augmenting people's lives by giving them access to that quality of care. So I think that is really there's such an opportunity with robotics to just increase the overall quality of life for everybody.
If you don't mind, would you share how your new robot will improve the?
Yeah. So this really quickly, this suit is designed to include robotic muscles, and those muscles actually sit in the front, and they would be the hip flexors, and then along the back, the hip extensors, and they're just like your human muscles, but they're anatomical muscles. They're outside of the body, integrated into the clothing. And the reason they're integrated this way is that we are helping your muscles around your core move, and our muscles at the core don't stop at our belt line. They actually extend across. So we have a really serious effort to provide people with strength and power assist in the suit, and you would wear it under your clothes. It has sensors that listens to your motion and then automatically adds support or movement assist based on the activities that you're doing.
Well, that's about as close to an overlap of robots supporting and working alongside people as you can get.
You can't get any closer in terms of how you're interacting.
Yeah, and that helps with mobility, and especially in the older ages.
Right. Yeah, this definitely is with our aging. The number of people that are aging, there's more people that need just some assistance with, and then there's people working in delivery vans and security guards, gardeners, people who are running and training and needing assistance when they're recovering. People who have had injuries. Like there's so many applications for this.
Yeah, I got to talk to you about my mom. Get her on your beta test program. I mean, she needs that support. So I'm going to quickly show a video of something that we recently released at Wonder Workshop called the Gripper Building Kit. So Regina, if you would play that video, if you would. Our robots they work right out of the box. You get to coding right away. But sometimes having a building project is a lot of fun. And so we're actually extending the ability of Dash Robot to drive around and not only grip things like a wall or a dive, but also lift it up and drive it around. That was great. So, I think that what is our message? What do we want to leave people with? What's the feeling that we want everyone to click the X on the window,
right,
and walk in, enter their day with?
Yeah, and so if I think like teachers walking into a room talking to their students should be saying, like, we have a lot of work to do. And you guys, we need you guys to get involved. There's so much opportunity to change and improve the quality of life of people in the world through robotics. But robots are also hands-on. Your best way when people ask me, hey, I'm interested in robotics, or I want to get a job in robotics, what should I do? And my first thing I say is dive in and get your hands dirty. You have to build robots. There's a great, I go to the robotstore.com is like a really simple place to go. There's tons of good examples of robots that you can buy there. But it's really getting kids to understand that, like, make sure they understand what is science fiction, and that everything else, because almost nothing has happened yet, is their opportunity to contribute, and that we need them to get involved, and it will change their life. Like they will find there's so many aspects of robotics. So I have apparel designers, I have industrial designers working side by side with electrical engineers, and there's room for everybody to get involved and understand robotics.
And we're right on the verge of something pretty amazing.
Yeah, I think it's like we're going to see more and more things happen, and so partly what's happened is that industrial robotics started 35 years ago, and we've mostly tried to build robots based on that technology, and now we're seeing with Cobotics more consumer-oriented robotics, and so we will see like the Roomba. You'll see the Roomba adding other kinds of things like the lawnmower, but maybe the Roomba becomes a mobile TV table in your house, and then we add arms to that, and so it will happen. And once that first platform emerges, someone asked a question earlier about AI, and it's really AI is too big of a term, but it's the software. The same way our computer had Windows 1.0, yeah. There's going to be robot software 1.0, and then 2.0, and then 10.0, and so it will happen exactly the same way. Yeah. And we're just starting. The cost, it's barely even begun yet, but it is starting right now.
It's an exciting time, and students are empowered. They're empowered to make a difference. So I want to open it up to questions, and there's been a lot of requests for where to get started. Where do I get started if I want to bring robotics and computational thinking into my classroom? And so we have somebody who I work with who's amazing, is Dylan. Dylan, if you would please share some of the great links that you're able to find that help answer the question of why, as well as help answer the question of how. And so you shared the NASA link that has some great resources. ISTE regularly posts great information about coding and robotics. And Wonder Workshop, that's where Dash&Live, that's where Dylan and I work. We have a ton of resources that you can take a look at online. And if you would like to bring robots into your classroom, Wonder Workshops is not a toy company that pivoted into education. Mm-hmm. From day one, we have a heart for educators. And so you'll see all of our content is really designed for the classroom. And so obviously EdWeb, who is amazing, we really appreciate the platform, being able to have this conversation. They're regularly having videos like this, and you can actually find videos from past conversations that Wonder Workshop has had. And so, and then obviously code.org. Many of you know code.org, but I mean, they're such a great resource. You have to throw them into the mix. So hopefully that's some good information. What is the resource that you have recently found that you think is a jewel that is really useful in your classroom? What have you found recently that is valuable? And please share it so that we can all benefit from your discovery. So, you're very we're getting a lot of thanks. So thank you, Rich, for taking the time out of your day. I know you've been. I pulled you in here from your very busy day.
It's important to me to be able to do this. I really do. This view of we need to tell the stories of the great future that are possible, because there's so many other stories that are out there now around robotics that are threatening, and so any opportunity I have to create a different perspective, I want to take. And so I do think the biggest thing is having kids feel like they can get involved. And there's never been a time when, with like FIRST Robotics, we haven't even talked about like robotics clubs and competitions, and like the best thing you can do is find a way for your students to get hands-on and to get involved and to feel like they can do that it's not that threatening or hard to do. Like it's just diving in and getting involved and just making it happen.
One thing before we break, I just want to really highlight something, and you touched on it, but I want to highlight this. Educators are shaping the future. And something you share with me is, a futurist doesn't have a magic ball. They're not able to. They're not predicting the future at all.
Right.
Like the thing that you share with me is futurists are shaping the future.
Right. Right. Yeah. The idea is that you want to help people. You want to help create the future by helping people tell the stories of the future they want to see emerge.
Yeah.
And I think that's what we want kids to be able to feel about robotics, that they can have a story about what they want robotics to do. And let's not react to some robot that makes you buy a cell phone. Let's think about how I can create a robot that can actually make a difference in the world, and that I still need to do it because it doesn't exist. It's not out there. We need people to get that message and to feel. I know it's not just true for robots; it's true for anything. But in this case, robotics has such an opportunity to impact just the way. I almost see us going to a different civilization if we really do this right, and changing the way people can live their lives.
Yeah. So I hope this has been informational to you, and I hope it inspires you to be futurists, to bring this message of hope and empowerment to your students, and to help them find their way towards solving some problems in their world. And maybe, just maybe, one of the solutions to those problems is robotics. Mm-hmm. And so if people want to learn more about your company, myseismic.com is where they would go. Wonder Workshop is at makewonder.com. So please check us out. Again, my name is Graham Ryland, and here with Rich Mahoney. All right, I think that was it. And with that, thank you all for joining us. It was really a joy. I think we all learned something. Yeah, I know I did.
Yeah, I love doing this, and hope it was valuable to all of you. Good luck.
All right. Thank you.